Hi everyone, welcome to today's webinar from Pearson Clinical Assessment. Dr Calum Hartley from Lancaster University will be going into detail on the impact of autism spectrum disorder on word learning. Thank you for joining us today, Calum.
Thank you, Rohan. I suppose a little bit of information about me. I'm a lecturer in psychology at Lancaster University, and I conduct research exploring the effects of autism spectrum disorder on children's development of language and communication skills. And that's what we're going to focus on in today's webinar, differences in children's ability to learn words, learn language across typical development and autism. So let's begin with some background context. Autism spectrum disorder is a neurodevelopmental disorder characterized by difficulties associated with social communication, interaction, as well as repetitive and restricted behaviors and interests. It affects approximately 1% of children across the globe, according to worldwide estimates, and it's more frequently diagnosed in boys than it is in girls. Now, although language deficits aren't a core diagnosis defining criteria for autism spectrum disorder, they are a significant and frequent characteristic, an important feature within the broader constellation of communication difficulties faced by children with autism. Many children with ASD experience profound difficulties understanding and producing spoken language. Indeed, delays in the acquisition of spoken language are one of the most commonly reported initial parental concerns that leads families to seeking diagnoses of autism for their children. While the vast majority of children and eventually adults with autism do develop the capacity for functional spoken language, approximately 25 to 30% of children are minimally verbal throughout childhood. And these children often present with very complex communication needs and alongside intellectual disabilities. And of course, their lives are very challenging. They have difficulty understanding the communications of others, as well as communicating effectively themselves. And given the significance and impact of language learning difficulties for children with autism, researching the profile of language development, strengths and weaknesses, and optimal learning conditions is an important global objective for research and a vital precursor for the development of effective interventions to better assist, scaffold children's learning of language. So thinking about how autism affects production of language. Whereas typically developing children utter their first words between around 12, 13 months of age, the first words of children with autism are often significantly delayed, 38 months on average, and around 30 to 50% are speaking in phrases at 4 years of age, which of course is a very common linguistic milestone in typically developing children. Children with ASD tend to have smaller expressive vocabularies than typically developing children of a similar chronological age. So they're saying fewer words. And both the content and the sound of children's productive language can be quite unusual. The way in which children with autism speak can sound different. It may be less varied in terms of pitch. It might have a monotone kind of quality to it sometimes. And also children with autism, many kids with ASD frequently produce echolalic utterances. So echolalia is the repetition of segments of speech that they've heard elsewhere. It might be that they're in a conversation with somebody and they hear their social partner say a sequence of words and then they repeat it immediately. Or it might be a section of script from a TV show or a favorite film that they've heard that they repeat over and over. Take, for example, the illustration on this slide. An adult caregiver says, "I want some water." The child then goes to the tap, pours them a glass of water, hands them the glass, but says, "I want water." In this case, the language that they're producing isn't actually what they're meaning. They're saying, "I want water," but what they're actually saying is, "Here, I've poured you a glass of water." And this is a good example that echolalic utterances might have communicative meaning for children with autism. They're not necessarily a bad thing. They might be an important means for the child to communicate. And also, they can provide time for children to process. They might repeat what's been said, giving them a window of opportunity to think about the meaning of what's required and the way in which they should respond. So as I've said, echolalia isn't a bad thing necessarily. Thinking about comprehension, most children with ASD understand fewer words than similarly aged, typically developing children. And the profile, the relationship between language production and comprehension is quite unusual in autism. About 30% of preschoolers with ASD show a linguistic profile characterized by almost equal receptive and expressive language abilities. And this is unusual because in typical development, receptive comprehension abilities significantly outweigh, they're significantly more advanced than productive abilities across every symbol system you can think of, whether that be understanding symbolic gestures, understanding language, understanding pictures, models, maps, so on. They're much better at understanding these symbols than they are at producing them themselves. So the fact that comprehension and production are almost equal in autism demonstrates or indicates that language comprehension and receptive skills are relatively more impaired than expressive abilities. And it's often observed that children with autism will say quite a wide variety of words without necessarily understanding what they mean. Now, across the autism spectrum, an important characteristic of language comprehension difficulties is challenges associated with understanding pragmatics. Pragmatics refers to social language, the use of language within dynamic communicative interactions. And this difficulty is present irrespective of an individual with autism's general linguistic ability. You can have people with autism that have excellent language skills, commensurate with their chronological age, or you can have minimally verbal children. And this difficulty with pragmatic language is common across those populations. And this manifests in difficulties understanding non-literal language, or rather the literal interpretation of non-literal language. Figures of speech like keep your eye on the ball or that's cool may be interpreted very, very literally. And this kind of difficulty has been associated with difference in understanding theory of mind. And theory of mind is the awareness that the self and others have mental states. And these mental states can differ from one another. They can differ from reality. So it's quite understandable, I suppose, that if you're a person that has differences in understanding others' mental states, then this could lead to challenges understanding communicative intent when people are speaking non-literally. So, having briefly reviewed the structure of language in autism spectrum disorder, we can move on to a question that drives my research that we'll focus on for the rest of this webinar. And that's whether delays in language development in autism are caused by differences in vital word learning mechanisms. And we're going to cover two different kinds of word learning mechanisms. We're first going to think about speech preferences, and then we're going to move on to processes that support children's acquisition of semantic meaning. So beginning with speech preferences. Typically developing children are born with an innate preference for listening to speech rather than non-speech. And they're particularly keen to listen to infant-directed speech. Now, infant-directed speech is a very special way of talking that adults spontaneously shift into when they're talking to infants. They also talk in this way when they're communicating with pets, funnily enough. An infant-directed speech, it's characterized by differences in pitch. It's often more high-pitched. It often has a sing-song type quality to it. And it includes redundant indicators of grammatical structure, and it facilitates word segmentation. It's also a lot slower. So the very way in which we speak to children, to infants, helps them to identify different words within a speech stream and to help them disambiguate meaning. Now, when infants are born, they have an incredibly diverse auditory perceptual system, to the extent that they're often referred to as the universal listener. And what that means is that an infant who's born into any country, any culture, has the capacity to discriminate non-native speech sounds with the same degree of accuracy as native speech sounds up until around 8 months of age. Now, by this point, 8 to 10 months, the ability to discriminate non-native speech sounds diminishes, whilst their ability to discriminate native speech sounds is retained. And what this tells us is that the process of listening to one's native language actually tunes the auditory perceptual system to better discriminate the sounds that it's hearing on a daily basis. So as we hear more language, we become better able to perceive language. Now, by contrast, for children with autism, they don't prefer to listen to speech over non-speech sounds, and they don't show a preference for infant-directed speech over adult-directed speech. And it's been suggested, and indeed there's evidence suggesting, that the absence of these preferences statistically predicts speech comprehension and production over time in children with autism. So those children with ASD who show the weakest preferences for speech in infancy prior to diagnosis actually result in having the most severe impairments in language development later on. And it's been suggested that this diminished preference for infant-directed speech could actually serve as an early diagnostic marker, although further research is needed because there is considerable variation across individuals on the spectrum. Now, enhanced auditory perception is a very common trait in autism. ASD is characterized by sensory differences and often over sensory stimulation, and the auditory processing differences factor into this, this broader sensory experience. Children with autism have increased accuracy on categorizing speech sounds, pitch, non-words, pure tones, lexical tones. They have enhanced auditory discriminability. And children with autism who have the most advanced or the most finely tuned auditory discrimination skills are actually most likely to be delayed in speaking their first words. And what this could suggest is that delayed language acquisition may actually result from the auditory perceptual system's failure to specialize in processing one's native language in infancy. So whereas in typical development, the process of hearing one's native language tunes the auditory perceptual system to discriminate those sounds, that process doesn't seem to be occurring for children with autism. They retain this finely tuned ability to discriminate non-native speech sounds and indeed sounds that aren't actually speech. And this could impact their ability to learn the meanings of words. So moving on to word learning mechanisms specifically. Words are verbal symbols that underpin everyday communication. So it's absolutely vital that children are able to understand and utilize their meanings if they're to navigate the social world. And given how early and how apparently effortlessly typically developing children acquire and start using language, it would be rational to assume that this must be a fairly straightforward process, but it is deceptively challenging. Infants, of course, when they're first born, they don't have any language, and they're born into a world that is rich with language. They are absolutely immersed in language. And of course, they don't know the meanings of any of the words that they're hearing. And the meanings of words are culturally specified. It's not the case that you can simply map any given word to any given referent, otherwise we'd all have different meanings for the same words and wouldn't be able to communicate properly. So the challenge faced by children is identifying what words go with what reference, when there are potentially innumerable potential referents out there in the environment. They have to narrow their attention down to the correct ones. And this challenge was beautifully illustrated by Quinn in 1960 with what's now famously known as the Gavagai problem. So imagine that you're an explorer visiting a foreign country for the first time, and you're communicating with a native. And whilst you're conversing, they point into a field and they say the word Gavagai. And you follow their point and you see a bunny rabbit running through the field. So what does the word Gavagai refer to? Well, your first instinct might be to think, well, it refers to the bunny rabbit. And indeed, that will be a logical and plausible answer to this solution, to this problem. But Gavagai could refer to lots of different things. It could refer to the bunny, but it could refer to running. It could refer to furry, brown. It could refer to food, or it could refer to the field, or any other potential referent in this visual scene. It's really difficult to know. Unfortunately, children bring to bear a range of strategies and heuristics that can help them solve the problem of referential ambiguity in word learning. So the process begins, having identified a new word in a speech stream, it begins with identifying the word's meaning. And this can occur over different timescales. It can occur sometimes in the context of the naming event. The moment the word is heard, sometimes it's possible to utilize social cues and environmental cues to figure out accurately the word's meaning. And this is called fast mapping. But sometimes fast mapping is not possible, and disambiguation of word meaning has to take place over time, over multiple occurrences and encounters with the word. And this is called cross-situational mapping. And either of these two routes results in the formation of a word-referent relationship, the first stage in word learning. Now, one way in which typically developing children get to the bottom of referential ambiguity that helps them identify the meanings of unfamiliar words is through the use of social cues. Speakers often orientate themselves towards the things that they're talking about, and typically developing children are very sensitive to where people are looking. They develop the ability to follow gaze, gestures, effect, engage in joint attention very early on in development, and they spontaneously refer to these cues when they hear people speaking, and consequently they tend to map unfamiliar words onto the objects that are the focus of a speaker's attention. This was classically illustrated in a study by Baldwin in 1993, where an experimenter and a child both held unfamiliar novel objects. Now, the experimenter waited until the child was looking at the child's object before looking down at their own object and issuing it a novel label, Modi, for example. Then the child was tasked with identifying the reference of this novel word, which is the Modi. And across the sample of typically developing children, it was reliably shown that they spontaneously consulted the speaker's direction of gaze and mapped the novel word onto the experimenter's object, rather than the object that they themselves were holding at the time and were looking at when they heard the word. They knew that it was important to consult the speaker's referential intent. Now, another way that typically developing children identify word meanings is through their understanding of how language works. Their mapping is guided by linguistic assumptions. So they use their existing knowledge of words that they have in their vocabulary, and this can help them figure out the meanings of other words. And one of these linguistic assumptions is called mutual exclusivity. And it's the principle that one word goes with one object. And they use this principle to assign novel words to unfamiliar objects when they appear alongside objects that are familiar that they already know names for. So in this example, on this slide, imagine a very strange situation where a child sees these three animals and they hear the phrase, "Look, an okapi." So the challenge faced by the child is, what is an okapi? Well, they know that it's not the animal on the left because that's a cat. And if it's a cat, it can't therefore also be an okapi. They know it's not the animal on the right because that's a dog. And if it's a dog, it can't be an okapi. So through process of elimination and the use of mutual exclusivity, children are able to narrow down their attention to the correct intended referent and map okapi to the only unfamiliar object that's present in the scene. But some word learning situations are highly ambiguous, and it's impossible to accurately fast map due to the absence of social cues or environmental cues that can help them figure out word meanings. So in this example, we're presented with two unfamiliar objects, and we hear the word blicket. So which is the blicket? Well, we haven't got enough information to answer that question accurately. Either of them could be the blicket. You may have a feeling about which one's the blicket if you make inferences based on sound symbolism, but we don't know reliably. Then we encounter another pair of objects, the same pair that we've seen before, but this time we hear the word Zepper. Now, both of these objects are already associated with the word blicket, and there's still nothing to separate them. They both, conceivably, could be a Zepper. Then we encounter a third pair. One of these objects we've seen before, and one of them is brand new, and we hear the word blicket again. Now, if we've been keeping track of the co-occurrences between words and objects, we can use those statistical correspondences to accurately infer that the green spiky object is the blicket. And the red object that we see previously, that must have been the Zepper. And the yellow object, we don't know the name for that. And this is exactly how typically developing children get to the bottom of identifying unfamiliar word meanings in these individually ambiguous situations. From 8 months of age, typically developing children are really good at tracking cross-situational statistics between words and objects, and can use these cross-situational statistics to accurately, reliably map word-referent pairings. So this leads us to the question, having identified accurately what a word means, the object that it might refer to, does mapping equal learning? Have we retained the word? Is the word now in our vocabulary, enabling later retrieval when we hear it again? Well, the answer is no. Extensive research with typically developing 2-year-olds demonstrates that they often forget new words just 5 minutes after identifying their meanings. Typically developing children, toddlers, are very, very good. They can perform almost 100% accuracy on a fast mapping task involving social cues or mutual exclusivity. But then you test them on their meanings 5 minutes later, and it's as if they're guessing, as if they've never encountered these words before. And what that tells us is that figuring out what a word means in the moment that it's heard is not sufficient for long-term learning, and therefore retention must be underpinned by a different psychological mechanism. Now, word learning and flexible use of language in general also involves generalization of words across contexts to previously unseen and unlabeled reference. If we had to hear words associated with their reference every time we heard them, language learning would take ages, and we would be unable to infer the meanings of objects that we've never seen before. We wouldn't know what their names were. And of course, that isn't how language works. Children are very good at guessing the names of objects that they haven't heard labeled through rules governing generalization. Now, many of the words that children first acquire in their vocabularies are basic nouns that refer to categories. And these categories, these words, they don't just refer to a specific exemplar, but they refer to groups of things. So for example, the word dog might first be learned in association with the family pet at home, but the child needs to learn that dog doesn't just refer to their family pet at home, but it refers to lots of other different exemplars out in the world that have certain similarities, but also they're very visually distinct. And the child's challenge is to identify the visual cues that determine category membership, whilst not really paying attention to the cues that are category irrelevant. And the cue that is most important that children end up paying most attention to, of course, is shape. The shape of something determines what it is, what the object is, and therefore what the label it should receive. Now, by 24 months of age, roughly, children develop another lexical heuristic called the shape bias. And this then governs their generalization of words and unfamiliar words that they acquire newly into their vocabulary. And the shape bias unfolds and develops in a sequence of steps. At step 1, it begins with the child mapping the same word onto multiple different exemplars of an object category. So they might map the word ball to a red ball, to a blue ball, to a green ball. Then, as they map more and more objects to the same word, they come to realize similarities across those objects. Balls are round, cups a cup shaped. And as they realize the similarity across members of more and more categories, they infer a general rule. X's are X-shaped. And once this general rule has been applied, they can utilize this rule when learning the names of unfamiliar things that they encounter for the first time. So for example, if the child goes to the zoo and they hear the word giraffe and they correctly map it to a giraffe, and then they immediately turn around and they see a stall selling plush toy giraffes, they can spontaneously extend the word giraffe to the plush toy because it matches on shape, even though it might differ in color and it differs on size. And as I said, children develop this shape bias around 24 months of age, or when they've acquired about 50 to 100 concrete nouns in their vocabulary. So the process of acquiring and learning object names tunes children's attention, their visual attention, to pay attention specifically to shape. So how does autism affect the identification, retention, and extension of words? Well, in terms of the use of social cues to support fast mapping, early studies show that children with autism who have language difficulties map labels onto objects that were the focus of their attention, rather than a speaker's intended reference. They didn't necessarily pay attention to gaze or social cues or emotional effect to identify the meanings of novel words, even though those cues were essential or are essential to accurately identifying meaning. So in a famous study, Baron Cohen et al. In 1997 replicated the method used by Baldwin that I talked about before in a previous slide. And rather than the child mapping the label onto the experimenter's object, which of course was the intended referent for Modi in this case, the child mapped the label incorrectly onto the object that they themselves were holding, the object that they were looking at when they heard the word, which was, in the context of this experiment, an incorrect word referent association. However, recent studies, and plenty of them, have demonstrated that many children with autism, including children with language delay, are sensitive to gaze and gestures and emotional effect when mapping word referent relationships. And it's now widely agreed in the literature that many children with autism can indeed utilize social cues when learning words under controlled conditions. Thinking about fast mapping, this is much more reliable in terms of consistency of findings. Children with autism across the ASD spectrum are very successful and accurate in their application of mutual exclusivity when identifying the meanings of unfamiliar words. Studies have demonstrated this ability in children with excellent language abilities, as well as populations that are minimally verbal. This seems to be a reliable and effective strategy for children with ASD to disambiguate word meanings. However, it's recently been suggested that children with autism may have some difficulty in terms of applying mutual exclusivity in certain situations. That is, ASD might disrupt children's ability to use mutual exclusivity with maximum efficiency due to idiosyncratic attentional preferences. So we know that children with autism have intense fascinations with certain categories of stimuli. And once their attention has been captured by a certain object or stimulus, it can be very difficult for a child to disengage their attention from that in order to explore their environment and benefit from the variability that's present. So take, for example, this mutual exclusivity-based fast mapping scenario. A child is presented with 3 objects, 2 of which are familiar that they have labels for, plus an unfamiliar object, and they are asked to identify the referent of Blicket. But let's imagine this child with autism is fascinated by trains. And of course, one of the familiar objects is a train. So this fascination leads them to be distracted by the train object, and they can't disengage from this object. They're captured by it. So they don't really notice the unfamiliar object, and they don't really notice the other familiar objects that are present. So even though the use of mutual exclusivity might be in their wheelhouse of language learning skills, they're unable to apply it because they're not paying attention to everything that's in their environment. Their attention is fixated due to their repetitive restricted interest. Now, cross-situational mapping, recent studies have demonstrated that the accuracy of cross-situational word learning is not atypical when you base your expectations on the children's language learning skills. Children with autism may be less accurate than peers, typically developing peers of the same chronological age, but when you base it on where they're up to in terms of their language development, they perform perfectly typically. That being said, their accuracy might be fine, but they can take longer to identify correct reference than typically developing children with similar vocabulary skills. And what that tells us is that there are important implications for when language is being presented at a fast rate, presented rapidly, particularly in natural communicative contexts. It's important to recognize that in these controlled experimental conditions, language is presented at a very steady rate, and children are often provided with unrestricted processing time. They can take as long as they want to respond and to think about it. So whilst their accuracy may not be any different under these conditions, if they're pressed for time when language is presented rapidly and they have to keep track of word referent associations in speech that is presented quickly, that could have an impact on accuracy. Indeed, language learning accuracy in cross-situational word learning is predicted by receptive vocabulary, which suggests that those children who have the most profound language deficits may struggle with keeping track of cross-situational word referent associations. So thinking practically, we know that children with autism across the spectrum can accurately identify novel word meanings when visual and auditory stimuli are presented in favorable ways. When children can utilize their existing knowledge of language to apply mutual exclusivity, when language is presented at a steady pace, when children can utilize their strong skills in associative learning for cross-situational word learning. However, attentional and sensory differences may impact children's identification of meaning under natural learning conditions. It may well be the case that children with ASD pay attention to social cues when they're highly salient, when they're really obvious in a controlled setting, but that doesn't necessarily mean they'll pay attention to those social cues or have the motivation to look for them in a natural learning dynamic social interaction. And of course, if children require more time to process language, then they are likely to have difficulty identifying word meanings in fast and continuous speech. In natural language, words are presented at about 150 words per minute, which is about 10 times faster than language presented in psychology experiments. So natural speech may well create a bottleneck for word learning that leads to these delays in acquiring vocabulary. So moving on to retention. Studies have paid relatively little attention to retention in autism so far. Much more attention has been paid to fast mapping, reference selection. But those studies that have explored retention in ASD have found that new words might require numerous converging attentional cues or increased repetitions in comparison to typically developing children. However, recent research demonstrated that the relationship between identification and retention of word meanings isn't atypical in comparison to vocabulary matched typically developing children. That is, they are about as accurate at recalling words after 5 minutes that have been fast mapped or have been acquired through cross-situational learning as typically developing children, suggesting that the relationship between identification and retention isn't unusual in ASD. And indeed, studies have shown that retention in ASD can actually be enhanced by providing highly salient social cues that redirect children's attention to reference after they have identified meaning for themselves. So in one of our recent studies, it was a fast mapping type scenario where children use mutual exclusivity to figure out word meanings for themselves. But then after they've identified the word meaning, the experimenter gestured towards the correct object, looked at it, and repeated its label. And we found that this social feedback actually increased the likelihood that children with ASD would retain these novel words after a 5-minute delay. We've recently found as well that retention of novel words is more accurate for language acquired through active cross-situational learning than for fast mapping. So when children use mutual exclusivity to fast map novel words. After about 5 minutes in our studies, we found that children with ASD could recall about 50% accuracy, 45 to 50% accuracy. However, when they've identified word meanings through cross-situational learning, through repetition, through keeping track of word-object co-occurrences over multiple instances, their retention is at about 65%. So a significant increase. And what this tells us is that the tracking of co-occurrences between words and reference over multiple encounters helps children to develop robust representations of meaning that degrade at a slower rate. They're less likely to just leave the child's memory after 5 minutes. They're more likely to be retained and recalled. And we've also shown that providing attentional cues during cross-situational learning can accelerate word-referent mapping and increase their accuracy of word-referent mapping without being detrimental to retention. So in one of our studies, rather than just leaving the child to keep track of word-object correspondences and that being their only way of identifying meaning, in one of our studies, we provided social cues. So a face actually turned and looked at the correct reference for the novel word. And that was a reliable cue to meaning. And we found that children with autism followed that cue accurately, and they were no worse when we tested them later on retention. But they were no better on retention either. So what that tells us is that providing these social cues, it doesn't necessarily increase the likelihood of retention after 5 minutes, but it increases their accuracy of statistical input because they're getting more and more correct pairings, right, between the word and the object, and it's helping them speed up their mapping of word-referent relationships. And together, over the long term, beyond 5 minutes, that could increase vocabulary acquisition. So thinking practically again, we know that children with autism may demonstrate better retention of words that they've learned actively rather than passively. Studies that show weaknesses in word learning in autism often involve experimental setups, where the child has to sit and watch something take place. And after they've watched this event, they're then tested on whatever they've learned through observation. In our studies, we actively engage the children in learning. They have to figure out independently for themselves what a word refers to. Even if a cue is provided, they still have to make a choice. They have to follow the cue and make a choice as to what the word refers to. And we find that in those situations, children with autism demonstrate learning that is commensurate with typically developing peers with similar language skills. We've also found that directing children's attention to word reference at the right time may have benefits for learning. Providing attentional feedback might increase the likelihood of retention following word-referent mapping, and providing cues that help children figure out word meanings for themselves to identify meaning can accelerate and increase the accuracy of their mapping, which could have long-term benefits. And repetition of word-referent pairings across time and context may be necessary to support long-term learning. It's not enough for a child to figure out or accurately identify a word's referent in a one-off naming event. That doesn't mean that that word has been learned. It could be that repetition across different times, different contexts, over different days is required for that word to enter the child's receptive or expressive vocabulary. So extension of meaning. We know that many children with autism really struggle to generalize information and behavior across different contexts. This is a real challenge for anyone who's delivering interventions. Promoting adaptive behavior in one context and then encouraging children to generalize it to different contexts or to different interactive partners can be really difficult. And this difficulty also manifests in the extension of verbal labels to novel reference. So despite possessing expressive vocabularies that exceed 100 concrete nouns, many children with autism do not appear to show a shape bias. So despite possessing an expressive vocabulary that we know is sufficient in typical development to support the emergence of the shape bias, children with autism aren't preferentially attending to shape. So that suggests a discrimination between, a discrimination between the maxims that govern word learning and children's development of a lexicon, their vocabulary. And one of our early studies, we found that minimally verbal children extended labels to pictures and objects based on color just as frequently as shape. Now, they did generalize based on shape, which of course is a category relevant cue. That's useful and that's correct, but they overgeneralized labels based on color, which is a category irrelevant cue. So, and by overgeneralizing labels, you're not going to be accurately mapping novel word-referent relationships as typically developing children would be. And it's been hypothesized that the absence of this shape bias in autism could be linked to lots of different cognitive processes. Differences in visual processing. So we know that children with autism encode and process visual scenes in a more piecemeal way. Rather than focusing or deriving holistic global meaning from a scene, they tend to pay attention to fine details, localized elements, and that's called weak central coherence. So it might be that when encoding novel objects, when they're learning words, they're not selectively attending to shape, or they are attending to shape, but they're also equally attending to other cues, texture, size, color, and linking the label to those cues just as strongly as shape. There is also differences in categorization, so how children organize objects and words into groups, and also potentially prototype formation. So when a child encounters a novel object and assigns a label to it, they form a prototype. And a prototype is like an abstract mental representation of the average for that category. So thinking back to a slide that I showed you previously about learning the word dog and how that extends to lots of different dogs that vary quite markedly in terms of lots of visual properties, a child, once they've learned the word dog, will have a prototype in their head of what a dog is. And each time they encounter something in the world that could potentially be a dog, it will be compared against that prototype. And if it sufficiently matches, the label dog will be extended. And we know that due to differences in visual processing and categorization in autism, there may well be differences in the kinds of prototypes that are being formed by children with autism. And this is a topic for future research. We have one of our PhD students at Lancaster who's currently investigating this in detail, trying to unpack some of the reasons and differences in cognitive processes that are underpinning differences in shape bias in ASD. However, typical shape-based label extension is observed when individuals with autism have unimpaired language development. So for individuals where their vocabulary learning is commensurate with their chronological age, or in children who have got delayed language, but their verbal mental age exceeds 4.5 years, rather than about 2 years. We've also recently found that generalization after 5 minutes is unimpaired in comparison to vocabulary matched typically developing children. So their ability to extend labels based on a mental representation rather than categorizing based on an example that is visually present, that seems to be strong and unimpaired. And together, these results suggest that the development of a shape bias in autism might just be delayed rather than qualitatively atypical. So in terms of practical implications, it might be that children with autism simply need to acquire a substantially larger vocabulary than typically developing children before they develop a shape bias. It might be that they just need more information about words and objects and how they relate to one another before they can figure out that shape is the key to constraining novel word-referent relationships. And that the need for increased data, that could be linked to these differences in the way in which children with autism perceive the world visually and the way in which they're categorizing stimuli. The preference for shape-based generalization and whether or not a deficit is exhibited in different situations could be dependent on the way in which it is being tested. So in those studies that show differences in shape bias tend to allow for categorization. So they'll present objects or words and they'll present a series of stimuli that a child could categorize as being irreferent. So they might present a series of pictures and say, is this oblicate? Is this oblicate? Is this oblicate? Whereas those studies that show intact or normal shape-based generalization tend to present forced choice options to children. So they might present 3 objects and say which one is the oblicate. So it could be the case that when one object is required, When children are forced to identify a single referent for a word, they do privilege shape as the basis for novel word-referent relationships. But when given the option to apply the word to lots of different things, lots of potential reference, that might be where this limitation in overgeneralization occurs. They might be more willing to overextend based on other perceptual similarities beyond shape. It's also possible, although it would need to be studied in future research, to accelerate the development of the shape bias, or to elicit the development of the shape bias in autism and potentially improve retention through training with multiple exemplars. So multiple exemplars simply refer to differently colored variants of a particular object that you're trying to teach the label for. And a study with typically developing children showed that it's possible to elicit the shape bias earlier in development by training children with multiple exemplars. And not only does the shape bias emerge earlier than it's supposed to through this training, but it leads to a surge in vocabulary acquisition. Now, training with multiple exemplars could be a way of helping children with autism identify the importance of shape, which could then help them acquire novel vocabulary. But this is a question to be addressed in future research. So to conclude, when expectations are based on language abilities, children with autism can learn novel words as effectively as typically developing children under controlled conditions. Extensive research now has demonstrated that the mechanics of word learning are often intact, at least at levels where you'd expect this to be based on children's overall language ability. Indeed, the relationships between these mechanisms don't seem to be qualitatively atypical. So this leaves us in an interesting situation where children who have got delayed vocabulary acquisition, delayed language learning, are demonstrating intact mechanisms for word learning in experimental situations. And so the objective for our future research and our current research is to figure out why that may be. And we believe it's the case that autism affects the efficiency of these word learnings by disrupting the intake of information in natural environments. The differences in sensory processing, differences in attention, differences in social motivation are leading to differences in the input of visual and auditory stimuli in natural learning environments that are leading to delays in acquisition, potentially alongside delays in the processing of language, when of course speech is presented at a fast and rapid rate and there's lots of distractions in the environment. So identifying optimal word learning conditions for children with autism is a really important priority, long-term research objective, and one that's necessary to really improve the provision of interventions to scaffold language learning. Thank you all for listening.
Thank you, Calum. That was a really engaging and insightful deep dive into the impacts of autism spectrum disorder on word learning. And we hope everyone watching this webinar found it valuable. Thank you all for joining us today. And thanks again, Calum, for taking the time to delve into this topic.